Hello, everyone, and welcome to today's Saratech enablement session. My name is Andrea Hall. You might have spoken to me many times on the support line. I am the Customer Relationship Manager here at Saratech, and I'll be your host today. Presenting today, we have Dan Nato, and he is an applications engineer here at Saratech. I'm sure that many of you have worked with him, and he'll be talking to you today about a few new features in Femap 12. This is part one of a two-part series, so stay tuned for the second part on the third Thursday of this month. Our sessions run about 30 minutes each, and they are all recorded and posted to our Saratech YouTube channel, so make sure that you check out the past sessions there. Twice a month we meet here the first and third Thursday of every month. We talk about tips, tricks, new and old features that'll help you in your everyday tasks. This is an open forum, so if you have any questions or comments during the session, you can type them in the questions box or the chat box over to the right, and I will just interrupt Dan and ask your question. If you'd like to save it till the end, I'll wait for a moment there at the end and see if there's anything else, any comments or questions. We also have a quick survey right after the session. If you have anything that we should follow up with you about, you can put a comment in the little survey there. We can follow up with you. And if you're ever not able to make it to our sessions, just go ahead and register for them, and then we will send the link out to you afterwards. We send them to the attendees and the non-attendees. So anyone who registered will get the link, and please feel free to forward that on to your friends and colleagues. And with that, I am going to pass it over to Dan.
Hello and welcome. Thank you for the introduction. My name is Dan Nato. I'm an application engineer here at Saratech. My expertise is in Femap, NXCAE, NXCAD, and NXNastran. So today I want to talk about Solution 200. So Solution 200 in Femap, I want to talk about design optimization and topology optimization. A couple slides just to go over some brief Femap information. So if you ever have any questions inside Femap and you need to get help, highly recommend press the F1. It'll get you to in-context help. Where to get help online? If you like to use online forums, you can use this Femap users community, and it's just inside Help Femap users community. And once you go there, it's fully searchable, and a lot of the Femap development team also posts there as well. The last is if you want to get help using NXNastran. To get help using NXNastran, help NXNastran, and here you have access to things like the quick reference guide, element library references, and then you have your advanced nonlinear and dynamics type guides as well. So on to the discussion for today. I want to talk about design and topology optimization. So it's support for Solution 200. So what they did in the new release of Femap is they updated workflow and they added support for this topology optimization. So here it just shows you the nice layout that they have now. So we just go ahead, we create our new analysis set, and then we have some optimization options. And inside there, we can specify if we're doing design or topology, what type of analysis type. We have some goals, we have some variables that we can set, and we also have some limits that we'll talk about as well. So what did they do? So new features. So they redesigned that interface like I just showed. So it's a lot better integration with an analysis set manager. It allows you to run multiple design studies within a single model. So before you could do linear, static, normal modes, and buckling. Now you can do frequency response, transient, and aeroelastic results. Now that you can also do different solution sequences and different subcases. There is also more design variables that you can set, so you can change material values. Just a lot more options in this new release. So here's just continue showing some of the things for the design optimization. So now some of the things that are prevalent are things like beam elements and solid elements. So for the topology optimization, just like for design optimization, we have these same sort of windows, which is really nice and easy for everybody to follow along. So once you figure out how to do, say, design optimization to move into topology optimization isn't too difficult. The menus should seem very similar. So, like I just said, it has a shared interface with design optimization, adapts very similar workflow. So topology optimization, we can only do solutions like statics, normal modes, frequency, transient, and buckling. And the element types that are supported right now are the 2D and 3D as shown below. We can also set up things for manufacturing constraints. One of the nice things that they added for this topology optimization is now once you solve your topology optimization model, now you can go ahead and export out the model as a STL file. Now what you need to do, and I'll show in the demonstration, is that you need to go ahead and create this new section where they called a criteria plot that they set up for doing these topology optimizations. So you set up your criteria plot, and then you would be able to export out this STL file. Okay, so what I want to do is open up Femap and just go through creating a design optimization and creating a topology optimization. And I think just showing how they're in use is going to really promote their usability. So let me start off with the topology optimization. So here's just a simple structure that I have, and I want to load it on the top, pin it at these holes, and see what type of material is not needed. You know, a lot of times you create designs, there's extra material, and all we need to do is really find out the load paths, and that's what this program is going to do a great job for us here. So let me go ahead and start with hex mesh in this part. And as you can see, I'm using the latest version of Femap, Femap version 12. I'm not going to get into too much of the nitty-gritty of some of the new stuff. I'm going to push that into the next release. But you'll notice right away, you have this icon right here. So it's very easy to change visibility. You can change directions that you're looking at it. One of the things that I really appreciate is if your model's out in space and you don't have access to it, you can just go ahead and hit this home button, and it'll go ahead and put the model right into the screen. So that's the shortcut, which used to be Control A. If you ever see this down arrow, if you click on that, it's going to bring you up the view options right away. Already in, you see view axis right here. All right, so let's go ahead and set this up to be hex meshed. So I'm going to say mesh, mesh control, size on solid. I'm going to go ahead and select the entities, and I'm going to specify that I want a hex mesh, and I'll just give it a different size here, and I'll accept my defaults. And now I'll say mesh, geometry, hex mesh solids. I'm going to go ahead and grab these entities. You can hold down Shift to make a box, hold down Control to make a circle, and hold down Control plus Shift to make a polygon. So in this case, I'm going to go ahead and load a material. I'm going to load up, I guess, aluminum in this case. And then I'm going to go ahead and mesh this with a solid property. Now that I have the part meshed, what I want to do is create some pads around these holes. So this is something that is new. So if you go into Meshing Toolbox, Geometry Editing, Pad, now you have the ability to split the solid. So now if I go ahead and I throw a pad on this, I'm just going to do them both at the same time by hitting Dialog Select. It's going to go ahead and break up. Let me put a washer on there. That'll be better here for this case. So I'll put a washer. I'll grab both sides. And it'll go ahead and update the model, and it'll cut it up into these regions. So now if you would mesh it, it would already have these regions. Okay, so let me just go ahead and mesh geometry solids, hex mesh solids, I'm sorry. Grab these entities. And now you'll see we have our part. If I go back to my model info, it broke those up into individual regions. I guess it's hard to tell with this background. So I'll go ahead and use my little highlighter, and you'll see now I have these individual regions. Now, one thing I'd want to do is a tools check coincident nodes and make sure all those nodes have been merged. I like to hit the preview, make sure there's some out there, and I'll hit OK. All right, so now let me go ahead and I'm going to create a group right now. So groups, and I'll call this the frozen area. So this is the area that I'm going to use that I don't want to be removed. So this needs to stay in my model when I'm completed. Now, I don't know how you guys like to create groups. I like to use this entity editor to help me control groups. So I'm going to go ahead and put this down here. And I'm going to go ahead and grab my group, and it'll populate down here in the entity editor. So group element ID, I'm going to say method in solid, grab these entities, use the highlighter, make sure I grabbed what I wanted. Looks like I missed one. And now, like I was saying with the entity editor, I like to go back, and now I can confirm what's in the group very easily. So if I just hit this ... I can hit the highlighter and I can visualize what is in the group. All right, so now I'm going to go ahead and create some boundary conditions. So loads, create a new one, just call it a force. And I'm going to create a constraint. I'll call it pinned. Now loads, I'm just going to do a simple load on a surface, grab this on a surface, grab this top face. In this instance, I'm going to put a downward load in the global Z direction of 200,000. So now I have my load applied. I'm going to apply my constraints. Now I'm just going to do on surface again. Now I could always select nodal and then change my method on surface to help my selection. But since I do have geometry, I'll make this easy on myself. And I'll go ahead and specify this as pinned. So now that I have my boundary conditions specified, what I want to do is set up the optimization. So I can go under Model, Optimization. And you see now this is a new setup. So you can go variables. So you can set these up ahead of time. But one of the nice ways of doing this is just to create a new analysis. And inside here, if you specify our Solution 200 Design Topology Optimization, which is number 8 in Femap, and you hit next through these commands, it'll bring you already to the optimization options. And this is just a different way of setting it up, and I believe it's the easier way. So in this case, I want to do topology optimization. My goal here is I want to minimize compliance. I'm going to do a static solution, but if you wanted to do normal modes, you could specify that as well. I'm going to go for 25 cycles. I forget what I did in for my example, but sometimes it might make sense to increase your cycles looking at your FO6 file. You can specify how you want it output. Do I want output at every improved? So that's a nice one to do. First and best is also just a quick way of getting it. One of the nice ones is all improved, but you are going to have a lot of output. It helps definitely see the load path as it's going along, but I'm just going to do first and best in this case. Here's to specify topology regions. So in this case, I'm going to go ahead and create a new one. And this would be the same as me going to model optimization. So I'm going to do a topology, and I want to specify elements that are active or frozen. You only have to specify one set. I'm going to grab my frozen ones. And since I already have a group that I called frozen, I can just add those to the list, and it makes it easier for me to select the elements that are frozen. So now I have my frozen elements. If we hit OK, and now if I hit next, if I wanted to specify manufacturing constraints, I could define them here. And you see some of them are, if it's going to be additive manufactured, symmetry is a common one that you'll use, extrusion, make sure it's going in the same direction that you want. In this case, I'm going to keep it very simple, and we're going to ignore this for now. I'm going to hit next through my options. And you'll see right now it's an optimization limit. So now I need to define my limits. So in this case, I could specify a displacement. So what I want to say is the nodal displacement in the downward Z direction of the elements. Let me reselect those. Method on surface. The elements on this surface cannot move. And I'll say it can go down, I'll go 1/10 of an inch. And then upper bound, I could put 0, I could put a positive number. Since the load's going down, it doesn't really matter, as I'm really concerned in this case about my lower bound. So I'll hit OK. Or I can hit more because I want to give it another response. So I don't just want to give me an output based on it can move down maximum this value, I also want to grab an entity such as weight. So right here it lists my starting weight, and here I want to go my lower bound. Let's just say I want it to go, put a multiply 50% less than it is, and its upper bound, I'll just put 20%. So I'm saying that here's my range. It can drop half its weight, but the maximum it can drop is half its weight, but let's drop at least 20% of the weight now. So we can just hit OK. Oh, I did that backwards. So we'll put 20, 50. Okay, that makes sense. So now here's my lower bound. It can drop down to this value, and it can go up to this value, which was 20% and 50%. So now we specify our loads and constraints. Make sure that you have your correct loads and constraints. And if you need to change any of your output requests. Now, since this takes a little bit to go ahead and solve it, let's just go ahead and imagine I went ahead and hit play, and I hit this solve to analyze those results. So I have the same model that I went ahead and solved, and now we can go ahead and look at something like our results. So like I said, I ran through and solved it, got results, and you'll see I actually ran it for 50 cycles, and it's saying my 49th cycle was the best one that I had. So I increased the amount of cycles by 2. So what you can do is look at your original model, and let's go ahead to our post-processing toolbox. And what they have is this thing called normalized mass density. So if we look at our original, it's all going to be the same. But if we go to our design cycle, you'll see this is the part of the structure that Nastran says that we should keep to minimize our compliance and go within those ranges that we said. So our max deflection of those entities and our weight is within those regions. So what we can do, and they added this now, is under View Advanced Post, there's a dynamic criteria. So now this is a dynamic criteria. Normally criteria plots have labels, but I toggled them off. And you have the ability to add and remove elements that fit in between these regions. So what I can do is I'm specifying anything above this value is what I'm displaying. So maybe I get it to a value that I see fit. You can hit OK, and now here's the proposed design. Now what you'd want to do is take this to your designer and be like, hey, we can remove some material from here. You see where we can remove material. Maybe you want to remove some and then make this stiffer. So we use this as our initial design. So one thing that you can do is you can do File, Export, Geometry, and now there's an option for topology optimization. It popped up, and it's a stereolithographic. And I'm just going to go ahead and put it at this top level. Test. And now what you could do is File, Import, Geometry, and here's that file. And it'll go ahead and bring it in. Now you see it might be a little bit rough. You could do some smoothing to this, so something like Mesh Smooth. Select the entities, and I'll just keep it as up to 20 iterations, and we'll keep it as it is. And you see we get a nice smooth model for this. But this is just something that is a great tool to get you the design what you need. What I recommend doing after this, after you recreate this in something like a CAD platform, is go ahead, bring it back into Femap and make sure your analysis is correct. So let's go ahead and step up over to a design optimization. So that's our topology optimization. And now our design optimization. So maybe I have this part that has all these regions, and what I want to do is I want to midplane it. And the idea here is I want to optimize this part to be as efficient as possible. And I can do that many different ways. In this case, I'm going to specify based on a stress case. So I'm going to say it can be, I'm going to go ahead and create a bunch of properties. So I'm going to say these properties can change thickness throughout some sort of band as long as they remain within, I don't know, I put like 20% of the yield. Now what you could do is specify this as like a frequency. So, oh, I want this first mode to be above 30 hertz. So you could specify it, and it could maybe make it thicker or thinner, the property values based on what you're looking at to make sure that your mode is within the range that you set. So let's go ahead and set this up to be mid-surface. So I can say geometry, mid-surface, automatic. I'm going to grab all these surfaces, and I'm going to use my little measure tool, make sure I'm smart snap from one point to another. And if you double click in any one of these second boxes inside Femap or any of these boxes, it will hit OK for you automatically. And you'll see that it filled in a value. So now what I want to do, and this came out in the last release, if you right click on the entity, you can specify this hide surfaces, and it will show you like a wireframe representation of the structure. So what I want to do is I want to imprint these curves into here so I can specify different regions and different properties. So using this meshing toolbox, I'm going to go to geometry editing, project curve. I'm going to imprint extend clean, which makes sure it goes all the way across. Into this surface down here, I want to imprint a couple curves. So I'm just going to go ahead and select a couple curves that I want to imprint. And let's go ahead and do it one more time. We'll imprint this curve. There we go. And now let's go ahead and hide that geometry. And now I have my midplane, which has all these separate regions. Now, one thing that I recommend doing anytime that you're doing midplane models is to do a geometry, surface, non-manifold add. And what this will do will combine all these surfaces together. And you see my tree right now, I have four pieces of geometry. It will combine them down into one geometric entity. And now you'll see that it's showing me the free edges of the geometry. So what this does is it basically combines, before there was two curves at these intersections, now they are combined as one entity, which really helps in the meshing process. All right. So now one thing that you can do if you did mid-surface using the Femap to mid-surface is you can do geometry, mid-surface, assign mesh attributes. And I'm just going to grab these entities. It will automatically create properties for you. I'll make it out of aluminum, 6061. And create properties based on thickness, and I'll say yes to this. And now if we look, it automatically created two properties for us. And you'll see down here it says no thickness available. That's because maybe it was a variable thickness and it couldn't figure out what it should use. So what you would technically have to do is go ahead and create those individual properties. And one thing with design optimization is I recommend creating as many properties as you think. You can even specify each element as its own thing that you can vary. So in my case, I'm just going to specify this range of properties. I'm going to create more as well. Looks like I'm running a little bit low on time, so we'll just say that I'm going to create the properties. I'll move to the next model. But one thing that we can do here is feature removal, loops, and you have the ability to add this surface mesh point. And one of the nice things is you could just go in here and grab this whole section, and it will automatically remove these entities. I don't know how well this shows, but as I remove them, it's creating a mesh point. So now if I would go ahead and mesh it, I'm just going to mesh it just to show you. I'll just mesh one little entity. You'll notice that, yeah.
If you need a little extra time, we can go up to about 40 or 45 minutes if you absolutely need to. Since we're recording it, we'll be sure to send it out to everyone. So it's more important to just get the content in.
Okay, good. So as I mesh this, you'll notice that the nodes do line up for these mesh points. So that's one of the nice things with adding surface mesh points when you do a feature removal loops. All right, so we'll just say I went ahead and created some manual properties there of those other ones, and you'll see these entities. So if I select on one and I go down, I created these all as separate properties. Now what you could do is you could create more regions and more properties, and we're going to go ahead and vary those properties as we go. So let's go ahead and set up this model for design optimization. So we set up the model. Now we want to go ahead and set up design optimization. So what we could do is under model optimization, like before, you could specify your variables, or like I showed in the previous one, we can just create a new analysis. Let's create a new one. And you could specify design topology optimization. Next, next, next. And we'll get to this same window. This time instead of topology, we want to do design. And like I said, in this case, I'm going to do static, But maybe you want to do normal modes and you wanted something to be within some frequency band, you could specify that. But I'm going to say static. My goal is to minimize weight. I'm going to do 25 cycles. And now I'm going to go ahead and specify some optimization variables. So you see, these are the optimization variables that we can specify. So you can go property, material. So here are those materials. So maybe I want to vary Young's modulus. So maybe I'm not too sure the material I want to use. Or I can change shear modulus, Poisson's ratio, mass density, CTE. So you see there's a lot more options than before. Element. So maybe I want to go to individual element and I want to vary their thicknesses. So this would be changing all individual elements. But in my case, I just want to change properties. And you'll see now I have all these properties defined that I can change. And I'll just do one at a time. So here's the first one. You can select multiple and you can do a percentage. So I want them to only drop 25%. But in my case, I'm going to say for everyone in the model, I want my minimum to be, I'll just put 0.01 inches, and I'll keep the maximum as it is. And if I just hit more, I can grab another entity. So I'll just grab another property, and I'll do the same thing. So my minimum, again, is 0.01. And you could do that for all the properties in the model. So we'll just say that I went ahead and I grabbed all the properties in the model, and I'm varying them, and I specify here's the bound. So I'm saying this property can go up or down. Now, the question is, where do you start the property thickness here? In my example, I started it where they were in reality, but you could put them in the middle and then you can vary it up and down. And you're going to get a little different answers depending on where you start those values. So some people recommend starting at the middle, the top, and the bottom of the range, and let the optimizer see which works best from there. So once you specify, those variables, in my instance, I went ahead and specified, we'll just say all the properties. I'll show you all completed then. Then we can go ahead and specify some sort of limit. So in this instance, the limit that I'm going to specify, you could do displacement, forces, stress, strain, frequency, volume, weight, etc. In my instance, I'm going to say stress. And now you'll see there's bars and available beams before. And I'm going to go plate top von Mises stress. And I'm going to specify a lower bound of, I'll just put 0, or you can put 1. And my upper bound, I'll just put 30 KSI. And I'm going to grab the elements that I want to vary. So I'm saying these elements can have a maximum plate top von Mises stress of 30,000. Looks like I have it in there, but that's okay. Make sure you have your loads and constraints. And one thing that I check here is element corner results, so that we only get elemental values, so that it's varying only the element itself. So after you would set this up, you could solve it. And I went ahead and I solved it. So once you go ahead and solve it, one of the outputs that you get are these functions. So you can look at these functions. I'm just going to grab them all, right click, and hit show, and it's going to pull up in the charting window. And you'll see this is as the entities change. So here's the original thicknesses, and it went through all these parameters. I did 25 cycles, and it looks like mine are starting to flatten out. So it looks like 25 cycles was enough. And you'll see some of these change in thickness as they go, and some of them push the limit towards the bottom, and some change a little bit less. So now these are all the variables that I specified, and you see as they go through all these design cycles. So what that does is it gives us new properties. So we define all these properties. And one thing that I should mention in this analysis setup that I did is if we go ahead and we look at our output request, I like to go ahead and hit punch and post-process, because if I send it to a punch file, now I have the ability under model optimization, there's update from punch. So what you could do is punch out the output, and then this one, you'll see here are my new properties, updated. So all I did was I went file, import from punch file, and now I have the values. So now these have new thickness values, and you'll see that they are varied directly from the output. So when you are running optimization runs, what I like to do is run a baseline. That now I have a baseline value. And then I'll run my optimization, then I'll have my new value. And you notice that my stress value, which I said limit, I think I said 30 KSI, and we're right up to our stress value that I specified. So it went ahead and varied all those properties up into that value. Now, one of the other nice things in the new release of Femap is you can click on this entity and it's movable. So I can change the scale. Maybe I want a user defined and I want maximum output, my 30 KSI. So I visually hit this. And like I showed you, this arrow will bring you to in context. So maybe you want to change some criteria style or levels on the fly. You can go ahead and do that. So maybe you want to change it blue to red. Go ahead and change those things on the fly. Other things is these are movable. So maybe you want to move it up to the top. Same thing for this, the other entities in the corner. If you want to go ahead and move them, these are also movable. Even is this tool for the icon. So if you see a reason to go ahead and move that. And then the one last thing that I want to mention, which I think is pretty neat, is under custom tools. Now there is a views themes. So on the fly, you can go ahead and go back to an original theme that used to be before, or maybe you want to go directly to a white screen. So now it's easy to go ahead and switch the background. You can save your own theme and go from there. So I hope I showed that there's a lot of powerful in this optimization. So it's under model optimization, and then we specify our variables, our limits, and if we do have manufacturing constraints. So this is a powerful tool using Solution 200, and they made it much more friendly in this new release. So in summary, I hoped I showed you guys a quick overview of design optimization and topology optimization, some of the power that they have there, their ease of use. And if you guys have any questions on using any of these products or, can I do this or that, feel free to shoot us an email. You can email me directly as well. So the next session is going to be on what's new in Femap 12. Mehdi's going to be performing this, and he's going to be performing a lot of the new intricacies of what's going on. So just a general overview, I believe. The reason why I waited is Femap 12 has not been released yet. It is scheduled to be released anytime soon. So if you're ready to take the next level, we do offer engineering services and additive manufacturing. So I just want to say thank you guys for attending. More information will be found at our website. If you use Facebook, this video will be posted onto YouTube. So thank you guys for your time. I appreciate it.
Yep. Thank you, everyone. Great job, Dan. Judy said, nice job today. So thank you, Judy, for your comment. Cameron has a question. He said, and you may want to follow up with him if you can't go back to your other screen, but he said, can you show us a view of how the path thickness changed with design optimization? And everyone, if you have to hop off due to time constraints, we understand. Please, I'm sorry, he said, can you show us the view of how the part thickness changed with design optimization? Thanks, Cameron, sorry. But everyone else, if you have to hop off, we are still recording. We'll send this out to you, and there will be a quick survey right afterwards, so just let us know how we did today. And Dan, I'll pass it back over to you to answer Cameron's questions. And if anyone else has questions, please feel free to add them to the question box.
Yeah, so here is with the updated thickness, and you can see this one's thin, and it seemed to thicken out this middle region thin, and then some reason this one became thick again. So there's that one model, and here's what it looks like to begin with, and we saw it had the step up. So compare this one to this one, you can see that it did try to thin out this section really good because it wasn't loaded very much. And I guess this region, because it's being bent, it adds some of those things. So it was really easy to update these with the punch file. You just go ahead and grab it, and it's going to go ahead and manually update it. So imagine if you had hundreds of properties and things like that. It automatically updates it on the fly for you. So. So with that, if no more questions, you guys have a wonderful day then.
Yes, thank you, everyone. Thank you so much. And make sure you visit our YouTube channel for lots more videos. We're putting shorter videos on there as well. So just subscribe to our channel and stay tuned. Thank you, and we'll see you at the next session on the 20th. Have a great day.